Hey everyone, today I'm going to be going over factorials and basically just explaining them and giving them two types of factorial problems. So the first thing is we want to know what factorial actually is and what it looks like. Factorial is just denoted by an exclamation point, and what it means is you multiply whatever number you have all the way down to 1. So if I had 4 factorial, that'd be 4 times 3, and then times 2, and then times 1. Of course, that gets me 24, so 4 factorial is equal to 24. 5 factorial, same thing, but this time we have an extra 5 at the beginning here, so then this would be 120, so on and so forth. So we'll just say 5 factorial equals 120. Now, let me erase this. I have two equations here for different things. So the top one is permutations, and the bottom one is combinations. And essentially what these are they show you how many combinations or ways you can order something when you're not replacing it. So if I had a deck of cards, 52 cards, and I took one out, that would then make it 51 cards, and then I took another one out, that'd make it 50 cards. That's why we use the factorial. And then we can order it in certain ways depending on whether or not the order of selection matters or not. So for permutations, the order of selection does matter, meaning that the order at which you select something will directly impact the next selection. So let's say for practice problems, let's say you have a set of 6 balls and you're trying to sort them to a group of 4. The way you would solve this is the total number of objects being 6 is n, so we'll have 6 factorial over, and now we're trying to sort it into 4 groups, and we're seeing how many ways we can sort these 6 balls into 4 groups, or a group of 4. So you would have the total number, so 6, minus the number that you actually want, so or the I guess number of in the set that you want. So since we want 4 balls in the set, you would subtract by 4, which is that 4, there you go, and then multiply factorial. So of course we know that 5 factorial, as I said earlier, is 120. So multiply that by 6, we get what, 720? Yeah, 720. So we get 720 over, now 6 minus 4 is 2. 2 factorial, well, we do 2 times 1. Oh, I had an extra factorial. Oops. So 720. And then over 2. And then we leave the factorial here because it's outside the parentheses. So when we have this here, 2 factorial is just 2. So we can say this is 360. So that would mean that we have 360 total ways we can order a set of 6 balls, assuming that the order of selection does matter. Now we can move on to a problem where order of selection does not matter. So this would be a combination, so it's very similar to the permutations, it's just that we multiply by k factorial at the end. So let's say we have a set of colors. We have red, green, blue, yellow, and orange. That's 5 colors, and we're trying to find how many ways we can order it into a set of 3, like the number of combinations. In this case, order of selection does not matter, so we can simply just, we can take colors in, but it doesn't matter what order we put it in because it's just, they're not asking for a specific criteria. It's not like if we had a classroom and we wanted to make a table where every other seat would be boy girl boy girl. That would be a case where order of selection does matter, because if you chose boy first, the next one would have to be girl. In this case, if you choose red, the next one doesn't have to be anything. You can just choose whatever. So as I said, there are 5 colors, so we do 5 factorial. And since we're not replacing colors, if we had red, we take red out, we don't put more red in, it's gone now. So that's why we use factorial. Then we have number of colors, so 5, and we're trying to sort it into a group of 3, and then we multiply by 3 again, 3 factorial. Now 5 factorial is 120. 5 minus 3 is, well, 2. 2 factorial is 2. And what do you 3 factorial is 6, because 3 times 2 times 1 is 6. So we can simplify this out to 120 over 2, and then we'll do, we'll do 3 factorial, which of course is just 120 over 12, which ultimately gets you 10. So there are 10 ways you can order a set of 5 colors into a set of 3. So this is just a quick factorial explained, and 2 practice problems for permutations and combinations. Thank you for watching.